So we're now on the module 11 of SRWE course. So for the module 11, we have switch security configuration. Okay. Okay, so introduction is, so the module of objective is configure switch security to mitigate LAN attacks. We have here 1, 2, 3, 4, 5. I think we have 5 topics here included in the module. So we have the implement port security, we have the mitigate VLAN attacks, mitigate DHCP attacks, mitigate ARP attacks, mitigate STP attacks. Okay. So we have here, I think we have here 2 packet tracers. So this module 11 is what is this? The all about configuration. Okay. So all the so all the topics or the introductory topics are on the module 10, so LAN security concepts. And now for the module 11, you just have to configure the devices. Okay. First one is implement port security. So we need to secure unused ports. Okay, for example, we have here the 24 ports, and there we only use the 3 fastest Ethernet connections. So it's a good practice to disable the 21 unused ports. So we can disable that by using the shutdown command, and we can enable it by the no shutdown command. Okay. We can also, in configuring a range of ports, we use the interface. So to configure a range of ports, we use the interface range command. Okay. So on this switch configuration mode, configure terminal mode, we have the interface range, the first number. So, for example, we have the interface range FA0/8 to 24. Mamaya ako ha. Next is mitigate MAC address table attack. So, the simplest and most effective.
Ba't ka naligo daw? Accidental naman lagi naman Ewan ko sa'yo, tinatanong ka na maayos.
The simplest and most effective method to prevent MAC address table overflow attacks is to enable port security. Okay. So port security, so we already discussed the MAC address table overflow attacks. So the MAC address table of the switch is bombarded with fake MAC addresses. Okay. So port security limits the number of valid MAC addresses allowed on the port. Okay. So by limiting the number of permitted MAC addresses on the port to 1, port security can be used to control unauthorized access to the network, shown in the figure. Okay, on the switch, we have here the set of allowed MAC addresses. So anything, any MAC addresses not on the allowed MAC address table would be blocked. Okay. So you can see here we have here MAC addresses that are not configured in the switch, so they are not be able to access the switch. Okay, so enable port security. So we have here the syntax. So first one, we have to access the interface, then switch port security. So before that, as you can see, the command rejected because the switch port security only the switch port security is only can be configured on access port or trunk port. So first we need to specify or we need to enter the command for the switch port mode access or switch port trunk. Then next is switch port security. We can now configure the switch port security. Okay. So this command is show port security, then the interface. So we can see the current port security settings, okay, for an interface. So after enabling the switch port for security, so we can now specify some of the port security commands. We have the aging, MAC address, maximum, and violation. Okay, so limit and learn MAC addresses. We have the set the maximum number of MAC addresses allowed on the port. Use the following commands. Switch port security, maximum, and the value. So it is integer. So as you can see here, we have the switch port security maximum, and then the value that can be entered is 1 to 8192. Okay. So the switch can be configured to learn MAC addresses on a secure port in one or three ways. So we have the manually configured. So we will be configuring the MAC addresses. So we will configure it manually, or dynamically learned, or dynamically learned sticky. So the main difference is stick them to run a configuration by using following command. Okay. Okay. Switch port secure MAC addresses sticky. Okay, this is the whole command. So specifying the maximum addresses available for the port, the MAC addresses, and the sticky. Okay. Port security aging. So it's the use to set the aging time for static and dynamic secure address on the port. So we have here two types of aging. We have the absolute and the inactivity. So the absolute is the MAC addresses on the port are deleted after the specified aging time. So for example, we have here the absolute. So the time is, for example, we have 10. So secure port are deleted after 10 seconds. So I think if it's not responding or inactive. So these are deleted only if they are inactive for specified aging time. So I think absolute. Let's see. Okay. So after the specified aging time. Oh, I think even they are active, they will be deleted after a specified time. For example, we have a new MAC addresses on the MAC address table. Say for example, after 20 seconds, it will be deleted. But in activity, so it will be deleted only if they are inactive. Okay. Okay. So switch port security aging, we have static, time, and then the type. Okay. So for static is enables aging for statically configured security, which is in the port. So the time is the aging time for this port, the absolute, and in the inactivity. Okay. So here in this example, we access the interface fast internet 0/1. We set the aging time of 10 seconds or 10. Okay, 10 minutes of inactivity. So the time is configured 4 minutes. It's not 4 seconds. Okay. Support security violation modes. If the MAC address of device attached to the port differs from the list of secure addresses, then a port violation occurs. Okay, by default, the port enters the error disabled state. Okay. So when the MAC address of device differs from the list of secure addresses. Okay. So here the switch port security violation protect, restrict, and shutdown. So for shutdown, so the port transition to the error disabled state immediately, turns off the port, and sends a syslog message. Okay. For strict, so it'll just drop the packets, but the port will not be shut down. Okay. Then protect is okay, it will drop and then it will send a syslog message. But in protect it will drop, but no syslog message is discarding authentic traffics. It's all for violation mode. Sends syslog message, so it's just for restrict and shutdown. Violation counter is also for restrict and shutdown, and then shutdown port is only applicable for shutdown violation mode. Okay, so this is the sample configuration command. Switch port security violation and then restrict. We can also display the port security configuration by entering this command. So you can see we have the violation mode set to restrict. So ports in error disabled state, we have here the sample message when it is disabled. So we can also enable the port. So after receiving the after being shut down port. So first we need to enter the command shutdown and then the no shutdown to make the port operational. So we can also verify port security. So port security for all interfaces. We have the command show port security. So for a specific interface, show port security interface, then the interface fast internet 0/18. You can also verify learned MAC addresses. So show run begin interface. You can also verify the secure MAC addresses. So show port security address. So it displays all secure MAC addresses that are manually configured or dynamically learned on all switch interfaces. As you can see, we have here 2 MAC addresses. So it's dynamically learned or secure sticky. Syntax checker, we need to implement port security. Okay, so we have here the packet tracer. We will be doing that later on if we have time. Okay. So you are currently logged into S1. Configure fast ethernet 0/5 for port security by using the following requirements. So use interface name 0/5. Enable the port security for access mode. Enable the port for access mode. Port mode access. This is port security. You need to enable the port security. Okay. Set the maximum number of MAC addresses to 3. So switch port security, then maximum 3. Okay. Statically configure the MAC address. Okay, just need to copy this. Switch port security, MAC address. Okay. Configure the port to dynamically learn to run configuration mode. So we have sticky. Then we need to return to privilege exec mode. Okay. So we need to verify the security for all interfaces. So show port security. Then enter the command to verify port security on fast ethernet 5. Okay. Show port security interface F0/5. Okay. So enter the command that will display all the addresses to verify that the manually configured and dynamically learned addresses are in their run configuration. So show port security address. So we have successfully configured and verified port security for the interface. So packet tracer will be doing that later on. So mitigate VLAN attacks. So just a VLAN attacks review. Okay. Steps to mitigate VLAN hacking attacks. So first one is we need to disable auto trunking on non-trunking ports by using switch port mode access. Okay, we will be getting it on a trunk. Okay, so disabled, we need to disable unused ports and put them in unused VLAN. Okay. So manually enable the trunk link on trunking port by using switch port mode trunk. We also need to disable DTP on trunking ports. So switch port no negotiate. Then we need also to set the native VLAN to VLAN other than VLAN 1 by using switch port trunk native VLAN and then the VLAN number. Okay. So for example, here we have the ports are active access ports. So we need to disable the DTP trunking, the auto trunking, by entering this command. Then 70 to 24, so are not currently in use. So switch port mode access and then assign it to an unused VLAN. Then 21 to 24 are trunk ports, so we need to enable it to mode trunk, then disable the auto trunking, and then set the native VLAN to VLAN other than VLAN 1. So in this example we have what? 999. Okay. So we have here syntax checker. So mitigate VLAN hacking attacks. So you are currently logged into S1. The port status of the ports are as follows.
Oh, ano ito? Saan ko ilalagay?
So fast ports 0/1 through 0/4 are used for tracking what are switches. 5 to 10 are used. 11 to 24 are active ports currently used. So use range. Okay, enter interface configuration mode for the trunks. So interface 0/4. So if you type in like this, will be error. Are used for trunking the other switches. So configure the interface as known. Assign to default VLAN. Okay, so switch ports it is used for trunking, so switch port mode trunk, and then switch port no negotiate. You need to disable the auto trunking, then switch port trunk native VLAN. So now we will be accessing this port range to 10. So configure the unused ports as access ports, assign them to 86 and shut down the ports. Okay, so switch port mode access, switch port access VLAN 86, and then shut down. So now we will be accessing this range of ports, interface range, then configure them to prevent trunking. Okay, for the active ports, okay. Switch port, mode access. So we have successfully mitigate VLAN hacking attacks. Okay. Next is mitigate DHCP attacks. So the goal of the DHCP starvation attack is to create DOS for connecting clients. So it requires an attack tool such as Gobbler. So recall that DHCP starvation attacks can be effectively mitigated by using port security. Okay, because Gobbler uses a unique source MAC address for each DHCP request sent. So, however, mitigating DHCP slippery attacks requires more protection. So Gobbler can be configured to use the actual interface MAC address as the source Ethernet address. So So, but specify different Ethernet address in the DHCP payload. So this would render port security inactive because the source MAC address would be legitimate. So the threat actor will use the real MAC addresses. So port security will be ineffective. Okay. So we have here the DHCP snooping. DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. So it then filters DHCP messages and rate limits DHCP traffic from untrusted sources. So DHCP snooping is all about trusting a port and then limiting the DHCP traffic from untrusted sources. Okay, so as here we can see, we configured the ports from the switches as trusted, and then all these access ports are untrusted. So steps to implement DHCP snooping. So we need to enable DHCP snooping by entering this command in global configuration. Okay, so IP DHCP snooping. We also need to specify the trusted ports. So we use this command IP DHCP snooping trust. And then we also need to limit the number of DHCP discover message on the untrusted ports. We use the IP DHCP snooping limit rate. And then we can also enable DHCP snooping by VLAN or by range of VLANs by using IP DHCP snooping VLAN. So global configuration command. Do we use DHCP snooping on VLAN? So we have here the configuration for DHCP snooping. So we have here the PC. So it is connected to the port of switch 1, so via fast Ethernet 0/5, and then the switch is connected to the server via fast Ethernet 0/1. So as you can see, the port here connected to the DHCP server is trusted. So all the access ports are trusted ports. So first thing we need to do is enable the DHCP snooping on global configuration. Then we also need to access an interface to be trusted, and then in this example we trust the port connected to the DHCP server, so IP DHCP trust, and then the range here, so 5 to 24. So 5 is untrusted port. So we limit the DHCP traffic limit rate to 6. And then we can also enable the DHCP snooping on VLANs. Okay. So we can also use the show IP DHCP snooping to verify DHCP snooping and show IP DHCP snooping binding to view the clients that have received DHCP information. Okay. Show IP DHCP snooping and show IP DHCP snooping binding. Okay. This is the untrusted port. Let's see. So 5 minutes. So the fast Ethernet is trusted. 5, 6 no. I have here the rate limit for 6. Then unlimited for the trusted ports. Okay. So syntax checker mitigate DHCP attacks. So we will be configuring DHCP snooping on this topology. Okay. So enable DHCP snooping globally for switch or IP DHCP snooping. So enter interface, choose the switch as interface interface range. Okay, so IP DHCP snooping trust. Then exit. So enter interface mode for the ports. Limit the DHCP message to no more than 10 per second. So interface range 0/. Then IP, DHCP, snooping, emit, wait. Okay. Exit. We also need to enable okay. So show IP DHCP snooping, verify DHCP snooping. Okay. So 4 gigabit 0/12 we have trusted ports. Okay, then show we verify the current DHCP bindings. So show IP DHCP bindings. Here capacitor network. VLAN 5. Next is mitigate ARP attacks. So dynamic ARP inspection. So the die requires the DHCP snooping and help prevent attacks by not relaying invalid or gratuitous ARP replies out to other ports in the same VLAN. So intercepting all ARP requests and replies on untrusted ports. To verify each intercepted packet for a valid IP to MAC binding. So dropping and logging ARP replies coming from invalid to prevent ARP poisoning. Then error disabling the interface if the configured die number of packets is exceeded. So the implementation guidelines. So we have the need to enable the DHCP snooping again. Then enable the DHCP snooping on selected VLANs. Enable the dynamic ARP inspection on selected VLANs, and then configure trusted interfaces for DHCP snooping and ARP inspection. So you can see, so it's the same with DHCP snooping. We also have the trusted and trusted port. So we have here the die configuration example. So we need to enable the DHCP snooping, and then DHCP snooping VLAN 10. So we enable the DHCP snooping on a certain VLAN, so which is 10. We also enable the die on VLAN 10, so ARP inspection. Then we also trust the port. For example, we have interface F0/24. So we trust that port and also configure the ARP inspection trust. Okay. ARP inspection. Okay. So they can also be configured to check for both destination or source MAC and IP address. Okay. So MAC address, source MAC, and IP address. Okay. So we have here the IP ARP inspection validate. So the ST MAC, IP, and source MAC. So we can also configure it as one. So source MAC is for syntax checker, mitigate ARP attacks. Implement die for a switch based on following topology and specified requirements. To enable interface range, will be trusting those ports and enable the DHCP snooping and die. Phase 2. Trust. IP DHCP, IP inspection. Trust. Okay. Then return to enable DHCP snooping and die for VLANs. So IP DHCP snooping VLAN 10, 20. Also have IP ARP inspection. Okay. We have successfully configured the for the switch. So mitigate SDP attacks. So we have here two mitigation methods. First one is port fast and BPT guard. So port fast is immediately brings an interface configured as an access or trunk port to the forwarding state from a blocking state. So bypassing the listening and learning states. So apply to all and user ports. Port fast should only be configured ports attached to end devices. So I think we have the port fast for as a mitigation for SDP, because on SDP, so a threat actor may act like a switch. So when a switch is port fast enabled and then it is connected to another switch, so it will create a loop. So next is BPTO guard. So immediately error disable support that receives a BPDU. So like port fast, BPDU guard should only be configured on interface attached to end devices. Okay, so when BPDU guard is enabled, so the switch the switch will can receive a BPDU guard, BPDU, but it will be the port will be disabled. So you can see here, access port for S1 should be configured with port fast and BPDU guard. Configured port fast, we have here the need to access the interface, switch port mode access because it is an access ports, then spanning tree port fast. So this command is used only for specific interface. So if you want to configure the port fast for all ports, we have spanning tree port fast default on config global configuration. Okay. So spanning tree port fast and spanning tree port fast default. So now for BPDU guard we have, so for an interface, so spanning tree BPDU guard enable. Then for all ports we have spanning tree port fast BPDU guard default. Okay. So first one is spanning tree port fast, then spanning tree port fast default. Then for the BPDU guard is spanning tree BPDU enable, and then for the global config is spanning tree port fast BPDU default, BPDU guard default. Okay. So we also have the syntax checker mitigate SDP attacks. Okay. So you are currently logged into S1. To complete the following steps to implement port fast and BPDU guard on all access ports. Okay, so enter interface mode for interface page F0/12 switch port mode access, exit, then switch port default. Right. Spanning tree port fast default. Okay. And for BPDU guard is spanning tree port fast BPDU guard default. Okay. So verify the port fast and BPDU guard is enabled by showing by default by viewing SDP summary information. So show spanning tree summary. Okay. Port fast is enabled. Okay. So I'm successfully configured and verified port fast and BPT guard for the switch. Module practice and quiz, we have here the packet chaser. So for the implementation of switch security for all switch, for security for a switch, all the integration. Okay. So the lab, so I think it's the same. So what did I learn in this module? We learn how to mitigate VLAN happy attacks. Okay. The DHCP snooping, steps for enabling DHCP snooping, the preventing the ARP attacks by using the DI or dynamic ARP inspection and DHCP snooping. We also okay, the steps on the implementation. Okay. Then the mitigation of SDP attacks. So we have the port fast and BPD guard. So module quiz, we have 15 questions. So what is the recommended best practice when dealing with native VLAN? So we need to assign it to unused VLAN. Okay. So assign it to a VLAN other than VLAN 1. So the VLAN 1 which is the default native VLAN. So on what switch port should port fast be enabled to enhance SDP stability? So it's for all end user ports, so access ports. So which command should be best to use on unused switch port if a company adheres to the best practice as recommended by Cisco? So we need to shut down all the unused switch ports. So which two features on Cisco Catalyst which can be used to mitigate DHCP starvation and DHCP snooping attacks? So we have port security and DHCP snooping. So what is the best way to prevent a VLAN happy attack? So we need to disable trunking. Okay. For disable trunk negotiation for the trunk ports and then set non-trunk ports as access ports. So it's disabling non-trunking. So which procedure is recommended to mitigate the chances of ARP spoofing? So we need to enable DHCP snooping on selected VLANs. So we don't enable the DI on the management VLAN. So what are the two types of switch ports that are used on Cisco switches as part of the defense against DHCP snooping and spoofing attacks? So we have the untrusted and trusted DHCP port. Okay. So which two commands can be used to enable port fast on the switch? We need to choose two. So on an interface we have span and tree port fast, and then for the enabling port fast in all ports we have span and tree port fast default on global config. So an administrator is troubleshooting connectivity issues on switch. Notice the switch port configured port security is in very disabled state. So after verifying the cause of violation, how should the administrator enable the port without disrupting network operation? So we just need to issue the shutdown command followed by the no shutdown. Okay. So network administrator is configuring DHCP snooping on the switch. So the configuration command should be used first. So we just need to enable the IP DHCP snooping on the global config. So network administrator is configuring DI or dynamic ARP inspection on switch with the command IP ARP inspection validate DHCP. So what is the purpose of this configuration command? So this command is to check the destination MAC address in the Ethernet header against the target MAC address in the ARP body. Next is which security feature should be enabled in order to prevent an attacker from overflowing the MAC address table switch. So we have the port security. So what layer to attack is mitigated by disabling the DTP or dynamic trunking protocol. So we have the VLAN hopping. So last two. So a network administrator is configuring dial switch. So which command should be used in an uplink interface that connects to a router. Just need to trust that port. Then where are dynamic alert MAC address stored when sticky learning is enabled with switch port security MAC address sticky. So we have the RAM. So this command is just for will be stick on the running config. So running config is on the RAM. So So we have successfully identified the correct answers. Okay, so introduction. So the next module would be VLAN concepts. So before we go to this, we need to do the two-packet tracer. Not feeling well, but Cisco is live. So that's it.